given data, we are going to plot our graph. So x values were given and y values also given: negative 15, negative 5, 1, 3, 1, negative 5 and negative 15. These are our x and y coordinates. Then the graph equation also given as y equals to 3 minus 2x cap. 3 minus 2x cap. This is our graph equation. Okay. And then you should plan your graph according to the given data. Okay, that means in x-axis, we just need negative 3 to positive 3. These are the values which we need in x-axis. That's the way you should plan your graph. In y-axis, the minimum value. In x-axis, we need negative 3 to positive 3. In y-axis, the minimum value which we need was negative 15 and maximum value was 3. Okay, maximum value was 3. Accordingly, let's plot our graph. Okay. The planning was very important. Otherwise, if you plan your graph improperly, okay, when you are started to draw your graph on the page, okay, that will come something like this. Okay, something like this. So there is no any continuation of this graph that's going outside. So otherwise, when you started to draw a graph like this, okay, that would be something like this. Other part of the graph going outside, okay, going outside of the page. So you should plan your graph properly before starting to draw that. That's our requirement. Yeah. First, in x-axis, we need negative 3 to positive 3. No? So it's enough like this. In y-axis, we just need from negative 15 to positive 3. That means in y positive region, we need only some values. But in negative region, we need many values. Accordingly, let's mark our skeleton was ready. Now let's mark our points. Okay, what are our coordinates? When x is negative 3, y is negative 15. So this is the place of that coordinate. Next, when x is negative 2, y was negative 5. Y was only negative 5. So here, next point. X is negative 1, y is 1. This point. When x is 0, y is 3. So this is the point. And next one, when x is 1, y also 1. When x is 2, y is negative 5. Here. Should be symmetrical one. Okay, your graph should be always a symmetrical one. If your points are not symmetrical aligned, just correct it again. When x is 3, y would be negative 15. So let's connect all these points and make a parabola. I have plotted our graph successfully. This is the graph y equals to 3 minus 2x cube. 2x cube. There are some questions, okay? After plotting your graph, we have to answer some questions. I'll read the questions. Try to answer with me. First one, what is the maximum value of this function? Okay, function means we are using the term function to indicate this graph. Okay, this graph is called as function. What is the maximum value of this function? So maximum value would be, this is increasing and decreasing. Maximum value would be this one. Okay, maximum value of the function. Value of the function, that would be positive 3. Okay, positive 3 is our maximum value. In here, if they were asked you to write maximum coordinate, okay, maximum coordinate, you should indicate 0, positive 3. 0, positive 3. Here only they were asked about maximum value. That means you should find its y value only. Maximum value means only y value. Maximum coordinate means 0, 3. That's the way you should represent your answer. Second question is axis of symmetry. Okay, you should find axis of symmetry for this plotted graph. Axis of symmetry. Okay, what would be our axis of symmetry? When you cut over here, can you get two identical pieces? No. This is the way we have to cut. Okay, when you cut your graph across this line, you will get two symmetrically aligned portions. So this would be your axis of symmetry. Axis of symmetry would be x is equals to 0. Okay, axis of symmetry means that's y-axis. No, y-axis is our axis of symmetry. So equation, write the equation of axis of symmetry. So that would be x equals to 0. To indicate y-axis, we are using x equals to 0. Through x is equals to 0, when you draw a vertical line, that would be our y-axis. Equation for y-axis, that would be x equals to 0. Next, third question. Write the range of x which function is increasing positively. Okay. Range function is increasing positively. These are some keywords to determine the answer. Increasing positively. This is our question. So we can split our graph into 4 portions. 4 different portions we can split our graph. First one would be this. Okay, I'll use different colors. Okay, this is your first region. Okay, in this region, what's happening? The graph, the function means you should find their y values. Okay, the values are negative and increasing. Starting from here to here, from bottom to top, negatively increasing. Here negative 15, negative 13, negative 10, negative 6, negative 5, negative 2. So negative values, all the values are negative but negatively increasing. This is the happening phenomena in this region. Next, this region. Let's identify this region. This region, all the y values are positive. Okay, all the y values, corresponding y values, 0.1, 1, 2, 3. Okay, y values are positive and y values are also increasing, positively increasing. Third region, this one. Here, look at this. All the y values. Function means the y values. Those are positive, but the values are 3, 2, 1, 0. What's happening in this region? Positively decreasing. In this region, the values are positive, but they are decreasing. We are not determining our x-axis. We are only considering about y-axis. Negatively. Function. Okay, function where what is the range, right? The range where function is increasing positively. That's our question. That's why we are analyzing this graph. Okay, this is our last region. In this last region, all the y values are negative, but negative 1, negative 2, negative 10, negative 12, negative 15. What's happening? Negatively decreasing. There are 4 different regions in same graph. We analyzed all of them. What would it be? First one, negatively increasing. All the values are negative but increasing. So negatively increasing region here to here, here to here, and here to here. All the values are positive and increasing as well. And here all the values are positive but those are decreasing. Here also the values are negative. All the y values are negative. Those are decreasing. This is the way you should analyze your graph. These are the 4 important regions in your graph. Okay, positively increasing range. Positively increasing range. So, range of x. Okay, range of x positively increasing. That means when the graph is increasing positively, you should determine the x range. X range in this region. This is the positively increasing region. So, in this case, you should find at where to where your x is located. At where to where your x is. What is the happening feature of x in this region? Y is positively increasing. They are asking about range of x when function is increasing positively. So here x is in between negative 1 to 0. Okay. When x is negative 1 to 0, function is positively increasing. X is negative 1 to 0. X is negative 1 to 0. That means greater than or equals to negative 1, less than or equals to 0. In this region only, the function was positively increasing. You should write this region properly. how I determined it. Okay, it's not a big task, it's little easy. We found the region. Okay, so we have to determine the range of x in between x, here -1, here 0, starting from -1 going up to 0. No need to consider about this green color region, that's positively decreasing. No? So positively increasing means only this region. In here, x values in between -1 to 0. In these two, what is the higher value? 0 is the higher one. Accordingly, you should plan your inequality. It holds, okay, it holds -1 and 0 as well. Here it has a 0 coordinate as well. So you should put equal mark in between x range. In between x range. This is the way you should find required x range when the function is increasing positive. Next question is about to find roots of this graph. Okay, roots, that means find roots of equation. I'll write the question. Roots of equation is given as 3 minus 2x star equals to 0. Equals to 0. This is the given data. We have to find roots of the given equation. How can we find the roots? There is no any data given. No. Accordingly, how can we find that? That's the thing we are going to determine over here. Look at the relationship between the graph we drew and the graph they gave. Graph we drew and graph they gave. These values are same, but instead of y, here that y was replaced by 0. Okay? Try to understand this. Other two values are exactly the same. 3 minus 2x square, here also 3 minus 2x square. Instead of y, the y was replaced by using now value 0. That means where y is 0, y is equals to 0 means that is x-axis. Previously I told you x equals to 0 means y-axis. Similarly here, y is given as 0. At where y is 0? At x-axis only y is 0. In other place, y will get positive or either positive or negative value according to the place of location. Okay. But here, roots of this one means y was substituted by this 0. So y is equals to 0. Y is equals to 0 means x-axis. Okay. Y is equals to 0 means that would be our x-axis. They are hiddenly asking you that to find where this graph intersected with x-axis. These are the two roots of this equation. Roots of this given function. Roots means where the function is intersected with x-axis. Sometimes it might be one value, sometimes it might be two values. According to your graph, it might change. So where the graph intersected with x-axis, these two are your roots. These two are your roots. So what are our roots? According to the graph, we can find the roots. When x is equals to -1, x is equals to -1, that is a root. Here, x is equals to +1. X is equals to +1. These are the two roots of the given function. Given function. How we found it? Y was replaced by 0. Y is equals to 0 means this is x-axis. They are hiddenly asking you that when you drew a graph, where that graph intersected with x-axis. Those two are the roots of the given function. So at two places this graph intersected with x-axis, -1 and +1. Those are the two roots of the graph.